Hello everyone and welcome to today's webinar, Debugging for Success and Accelerated Platform Bring Up. Our presenter today is Soflen Shih, Technical Consulting Engineer in the Developer Products Division here at Intel. During this presentation, please send in any questions you may have and we will get to as many of them as we can during the Q&A session at the end of this presentation. We now turn the time over to Soflen.
Hi, I'm Soflen, working in Developer Products Division as a Technical Consulting Engineer. In this video, I'm going to talk about how Intel System Studio can help you analyze the issues found in the system bring up stage and going to share two use cases at the end. Our topic is to introduce a powerful software package and how it can assist the engineers on debugging. So, at the beginning, I will introduce the software package named Intel System Studio. Then, I will talk about what debug components and what debug capability it has. However, the debug software cannot work alone. It requires a physical debug connector to connect the host to the target machine. So, I will go through what connector solutions we have for Intel System Studio. After that, I will bring you two use cases and show you how our customers analyzed their issues by System Studio. My Developer Products Division has a comprehensive suite of tools called Intel System Studio. It contains compilers, libraries, performance analyzers, profiling, and debugging tools. It provides a total solution for developers from platform bring up, power and thermal tuning, system performance profiling, software application compiling, and to library support. The ultimate goal of Intel System Studio is to accelerate every layer's development speed. Back to our topic, what I want to emphasize is the tools for accelerating the platform bring up. The category debuggers has three sub-tools. There are System Debug, System Trace, and Intel Debug Extension for Windbg. And the number of the sub-tools is still growing. There are some new features are ongoing development and will be added in the near future. From this architecture chart, we can tell that the debuggers has three layers. The top layer is the Target Connection Assistant, abbreviated as TCA. It helps users to configure the target platform and the hardware prop. Then, the three sub-tools in the middle layer try connecting to the target device based on the configuration set by TCA. All these three sub-tools have their own functions, and I will introduce them one by one later. The bottom layer is the connection engine. It assists sub-tools to communicate with the Intel platforms through JTAG or through Direct Connect interface. The first debug tool of the Intel System Studio is called System Debug. It helps users to do source-level debugging on UEFI code or on Linux kernel code. If the BIOS or Linux kernel is built in with symbol files, the image will contain the symbol information. Then the user can load symbol files and see the C code after connecting to the target device. Moreover, System Debug provides users with the capability to control CPU The user can hold CPU and step to the next instruction pointer. The user can also set a breakpoint with or without a condition and let the CPU keep running. When the CPU hits the breakpoint, the process will be halted, and the user can do stepping from the breakpoint. Setting breakpoints and stepping are the common usages in source-level debugging. When Intel customers start a new design and try to enable it, they may face a bunch of issues. If the issues happen in BIOS boot up phase, System Debug can help to narrow down the root cause. Maybe the process is stuck in a while loop, or maybe something's wrong when loading EFI modules. The user can hold CPU, check the source code, and step-by-step track the instructions with a System Debug. More than that, System Debug has other useful features. You can find them in the how-to videos after the webinar. The second tool is named Intel Debug Extensions for Windbg. As you know, Windbg is a software debug tool developed by Microsoft. It can help to analyze several kinds of issues happen in the Windows drivers or in the Windows frameworks. But Windbg relies on some debug drivers to pass the debug messages to the host machine. However, when the hang issue happens, these debug drivers sometimes stop working. In that case, the host machine will not receive any debug messages from the target device. That's why Microsoft and Intel co-work and develop the debug extension tool to enhance the Windbg. This Intel debug extensions for Windbg connects to the target device through Intel Direct Connect interface. When the hang issue happens, if the CPU is still working, the user has chance to get the process state and its address. With the extension and the Direct Connect interface help, the Windbg, which is running on the host machine, can still handshake with the target CPU and pass some useful debug information for analysis. The last tool is called System Trace. As its literal meaning, System Trace is for collecting the trace logs for ME and BIOS. It can also capture the architectural event trace messages such as I/O, system management interrupt, and system events. Intel ME team, as the customers, always attach the ME trace logs when they report ME issues. But unlike BIOS logs can output from the serial port, it requires Trace Hub's help to collect the ME logs. The Trace Hub here is a component in Intel PCH. It can collect debug messages from several sources and output the messages to Direct Connect interface. It also benefits BIOS engineers because they don't need to remove the housing of the product and don't need to mount a serial connector for getting BIOS logs. In order to connect both host machine and the target platform, it needs a physical connector. We call this kind of connector as a prop. There are 3 available props supported by Intel System Studio. They are ITP-XDP3, closed chassis adapter, and DCI USB debug cable. The ITP-XDP3 goes JTAG interface, and can directly connect to the CPU on target platform. But the price of ITP XDP3 is not friendly to customers. It reduces their willing on analyzing the system bring-up problems with the debugging tools. That's the reason why Intel developed another debug interface called Direct Connect Interface, abbreviated as a DCI. The DCI is a physical path on PCH. Intel designed two probes to connect to the target platform through DCI. One is closed chassis adapter, abbreviated as a CCA. This powerful adapter can start working when ME is ready, which means it provides debugging capability in the early stage. The price of it is much cheaper than ITP XDP3 and affordable for all customers. Unfortunately, with the powerful debugging capability, CCA has some hardware limitations. It requires the target platform provides a USB 3 port without signal redriver, hub, nor retimer. This hardware requirement restricts customers' products on form and on spec. So, Intel decides not supporting CCA anymore after Ice Lake platforms. The alternative DCI probe solution is called DCI USB native debug class. It has two types, USB 3 and USB 2. USB 3 supports a higher bandwidth than USB 2 on data transfer, but USB 2 can finish initialization earlier than USB 3. USB 2 can start working when ME is ready, but USB 3 has to wait until the middle phase in BIOS boot up sequence. It's a table showing the available probes for different platforms. Users have to choose suitable probes for their target platforms. And you may notice that CCA is not the available probe for all Atom series. The trending of available probe usage for external customers and for future platforms will be reduced to only one solution, which is DCI USB native debug class. In 2018 Q1 Coffee Lake workshop, a critical system boot up hand issue was reported. This issue only happened on the DCI-enabled platforms. When DCI was enabled on the customer's Coffee Lake platform, it had a big chance to hang with the black screen, and the process was stuck at the BIOS boot up sequence. However, it's not easy to tell what the root cause was, only from the symptoms. So the customer tried using Intel System Studio to analyze this issue. In doing so, they used our system trace to get the dying messages. In this case, the dying messages was the postcode number. The last two messages they got were the postcode 69 and 78. And the postcode was sent out from the I/O port 80. So their next move was to use System Debug to set an I/O breakpoint at the I/O port 80 and to set the condition where the value equals to 69 and 78. When the process stopped, System Debug showed the exact function name and the assembly code. Then the customer step-by-step checked what the BIOS code did before it hung. With System Debug's help, the customer found that the process was stuck at a day loop. And the reason why the process was dragged into this state loop was because the system couldn't get available MTRR. So the customer dumped the MTRR table and compared it with the normal one. At the end, they provided this information to Intel BIOS team for accelerating the issue analysis. The snapshot on the left side is system trace, showing the debug messages from CSME and BIOS. And you can see the last two postcodes, 69 and 78. The postcode indicates the process is still in BIOS SEC phase. The messages fetched by system trace are quite helpful to narrow down the issue. And the snapshot on the right side is the assembly view in system debug. When the customer followed the postcode 78, it brought them to this assembly code and pointed to a dead loop. The line in red square means that the process jumps to itself. It only happens when BIOS cannot allocate an available MTRR. From this case, you can see system debug is a handy tool for source level debugging. This case, or you can say story, is about how a third-party vendor used the Intel debug extensions for Windbg to debug their kernel driver. One of our customers adopted a third-party solution in the project, but it had a chance to meet a hard-hand issue during the third-party driver initialization. The fail rate was low, but the problem was critical. From the system, Intel debug team believed the root cause should be in PCH or in the driver itself. So they wanted the failed machine have a DCI enabled to get the PCH dump. Meanwhile, the third-party engineers wanted to debug their driver by Windbg. However, there's a restriction that DCI cannot coexist with the normal Windbg. In other words, the third-party vendor cannot connect to the target machine via USB in Windbg when DCI is enabled. Therefore, the only way to enable DCI and to debug with a Windbg at the same time is using our tool, Intel Debug Extensions for Windbg. The first step, the driver needs to be built in the debug version, or there's no debug messages output from our tool. So the customer asked the third-party vendor to provide the debug mode driver and then install it onto the failed machine. The next step was running Intel Debug Extensions for Windbg on the host. After the target platform gets into Windows, the customer started capturing the kernel debug messages output from the driver. They rebooted the target platform several times and finally reproduced the hard-hand issue. Then the customer shared the debug message to third party for analysis. And Intel debug team could connect DCI and run their tool to read PCH state and get some registers. So this is how Intel Debug Extension for Windbg looks like. It has an assembly view showing the process on CPU core 0, and a command view showing the debug messages and the commands results. The tool has provides a cheat sheet showing the available commands for debugging, and it can show memory and registers content. In this use case, With our tool's help, the customer got third-party driver logs in the command view and provided the logs to third party for analysis. We can say Intel Debug extensions for Windbg successfully accelerated the issue's clarification time. All right, let's recap what tools we learned in this video. The Intel System Studio package has 3 debugging tools for engineers. They are System Debug, System Trace, and Intel Debug extensions for Windbg. The purpose of these tools is to shrink the debug time to achieve time to market. System Debug is the tool for source level debugging. It can show C code of the current process for UEFI and Linux kernel. It also provides several kinds of breakpoints. Users can track the source code to point out where the suspect is. The next tool, System Trace, is for collecting debug messages for several sources. There's no need to do hardware rework for getting the debug messages from the failure product. The users can start with a running System Trace to classify the issue belonging before they dig deeper. The last tool with a long name is Intel Debug Extensions for Windbg. This tool was mainly designed to deal with the situation that the general Windbg cannot work because of the soft hand issue or because of a special case like our second use case. So if the system hangs in Windows OS and the CPU is still working, the users can use our Windbg extension tool to debug the Windows kernel drivers as what they did before on Windbg. That's all my presentation. But the next time you have a system bring up issue, hope you will consider Intel System Studio as a one debug tool solution.
Thank you, Soflen, for that insightful look at Intel System Studio. We have more time and several questions have come in, so let's wrap up this session by answering some of them. And the first question for you, Soflen, is, in the BIOS domain, some individual BIOS vendors, such as AMI, Inside, and Phoenix, have their own debugging tools. They also share the tools to OEMs and ODMs. What's the difference between Intel System Studio and their tools? Also, there's a two-part question. So what's the difference between Intel Studio and their tools, and what's the benefit of using your tool instead of using theirs?
Okay. So the biggest difference is on the interface. The tools from BIOS vendors connect to the target machine through the normal USB. If the issue happens in the early BIOS boot up phase, their tools cannot work because the USB is not ready yet. But Intel System Studio is using a special interface called DCI, Direct Connect Interface. It can still work in the early boot phase. Yeah.
All right. Second question is, who typically uses the debugging tools that you covered today?
So our main customers are OEM, ODM, who have their own BIOS and software engineers. In order to save BOM cost, they change the components frequently, right? So many issues happen when they change a new component. So maybe it's a hardware issue, or a BIOS configuration issue, or maybe it's a driver issue. No matter what the root cause is, OEM audience can do triage first with the debugging tools of Intel System Studio.
All right. So we have another question from a viewer of the webinar. Question is, I've heard of a debug tool with a DCI interface called SourcePoint. What are the differences between SourcePoint and Intel System Studio?
Okay. The Intel did authorize the third party to connect through DCI for running their debug functions. So the debug tool is named SourcePoint. But Intel System Studio and the SourcePoint target to different levels of the customers. For the SourcePoint solution, users have to buy an expensive product first and pay annual license fee for using the software SourcePoint. But the annual license fee for Intel System Studio is much cheaper. And we have a special program for OEMs. It's almost the cost zero to them. Yeah, I think that the cost will be the main difference.
All right. I'm going to finish with two more questions. Is there any prerequisite before using Intel System Studio for debugging? So is an Intel architecture machine a connector, and downloading the tool enough to start?
Not every Intel platform can support DCI, so you need to check if the combination of a platform and a connector, which is a prob, is in our support list. If it's in our support list, and the BIOS also needs to enable its debug function. So if you can build the BIOS code by yourself, you have to enable DCI for establishing connection and enable CPU debug function to be able to hold CPU and do source level debugging. But if you don't have a BIOS code, you will need to ask the platform vendor to give you the BIOS image with the debug enabled.
All right. Actually, I'm gonna fire two more questions at you. It seems nowadays almost every Wintel product has multi-cores inside. Does System Debug support? Does Intel System Studio Debug support multi-cores debugging?
Unfortunately, our Intel System Studio doesn't support multi-core source level debugging yet. But we do get the request from some customers. So our engineering team starts to study the possibility of developing this feature. If they decided it's a doable function, the target date will be in the next year.
All right, so something to look forward to there. Final question for you, Soflen. Is it possible to run two debugging tools for two different target platforms at the same time?
Still, unfortunately, one target platform at a time is the current design. So our low-layer engine, which is for host target communication through DCI, restricts the number of platforms can connect at a time. So, but there is a tricky way to support multiple targets with only one host machine. In System Trace, you can ask a trace hub, not streaming the messages to the host, but save the messages in the buffer of a trace hub instead. After the users enable the buffer and let the trace hub start capturing, they can disconnect and move to the next target platform and set up a new connection. Then ask Trace Hub to capture the messages and record the logs in the buffer and repeat the same steps. So once the issue is reproduced, they can fetch the logs back from the Trace Hub buffer. Usually, in the customer's factory, they let hundreds of products running overnight to replicate some critical issues. In that case, System Trace would be a good choice to collect messages from the virtual machine.
All right. Well, folks, we're going to wrap it up right there. I want to thank you again, Soflen, for today's presentation, and thank you to everyone for joining us. Please do explore the Tech Decoded website for more information on Intel System Studio and other powerful and helpful Intel software tools, including how-to videos, articles, download links for Intel products, and other resources to help you. Thanks again to all of you for joining us today.